Welcome back to the microbes in human welfare. In this class, we are going to start with the next part, which is regarding microbes in sewage treatment. Okay, now regarding the part of microbes in sewage treatment, we also call these sewage treatment plants as a STPs. Okay, so this is also called as a STPs. Sewage treatment plant, which is called as a STPs. Okay, now what is this sewage? The municipal waste water is called as a sewage. We came across the definition of the sewage. Now this is the recent problem, the current problem which we are facing in all the metropolitan cities regarding the part of the sewage water. The sewage water has to be managed because the sewage is produced due to increase in urbanization, and the waste water that is generated in the homes, in the hotels, in the offices, schools or industries, irrespective of that, majorly sewage refers to domestic waste water that is generated in our homes as well as even in the apartments also, okay, which is called as sewage. So let's look at the definition of the sewage here. Now sewage is municipal wastewater. Municipal wastewater. This is termed as a sewage. So what is sewage? Municipal wastewater is said to be sewage. Now sewage water is generated mainly from the homes, from the houses, either washing the utensils or washing the clothes. So this sewage water is generated. Now this sewage water is generated in less quantity in the villages. If we come to the cities, it is generated in little bit more quantity. Suppose if we go to the metropolitan cities like Mumbai, Chennai, Bangalore, Delhi, Gujarat, suppose if we go there, the sewage water produced is in large quantity in terms of millions of gallons of liters. So how it has to be disposed? Suppose if the sewage water is let into the aquatic water bodies, then it leads to death of the aquatic life like fishes and other organisms. Due to lack of oxygen, these microorganisms will die. So the sewage water has to be managed. The pollution of the water has to be controlled. So how it has to be controlled? So earlier, when the sewage water was released into the aquatic water bodies, it led to lot of problems. And in fact, in our rural areas, we are using the river water back for the washing purpose, even for the washing of the utensils also, clothes also. So that's why sometimes the same water might be used for the drinking purpose also, and it leads to lot of diseases because it contains a lot of pathogens. That means sewage water contains majority of the microorganisms that may be useful or that might be harmful, but majority of them are harmful only. It cannot be used directly for the human use. Okay, it is unfit for the human use. Okay, what is termed as the sewage? Okay, now if you want to look at the sewage water in large quantity, if you go to any of the metropolitan cities like Mumbai, Bangalore or Chennai, on the outskirts of the cities you can see a large river which is flowing. That is not a river, that is the sewage water. Look at the quantity of the sewage water that is flowing every day, because all the cities are busy cities which will be working 24/7. As a result, lot of sewage water will be produced, lot of municipal water is produced. So where it has to be disposed, where it has to be released. Sometimes the sewage water is also used for the agricultural resources, but how much we can use, because plenty of water is generated every day, and hence the sewage water has to be managed in such a way that there should be construction of a sewage treatment plants, where we call it as STPs. By producing these STPs, we can minimize the water pollution. We cannot make it as zero, but we can minimize the water pollution. Okay. Now, regarding the sewage treatment plants, there are majorly two steps by which we are controlling the sewage water. So the steps are, it includes primary treatment, and second one is a secondary treatment. So there are two steps which is used in the STPs to control the municipal waste water. In the sewage treatment plants, we are using majorly two steps. The first step is a primary treatment, second step is a secondary treatment. Now, what is this primary treatment? We have a diagrammatic representation of this. First, let's say what is a primary treatment, and then later on we can go into the secondary treatment. This secondary treatment is major because it is also called as a biological treatment. So let's see the primary treatment here. Now, primary treatment, it includes filtration and sedimentation. It includes two steps where we call it as a filtration and sedimentation. So these are the two steps of a primary treatment. Then what is this filtration and what is this sedimentation? The waste water that flows, a screen is placed on which the water comes and flows. Then through the screen, as the screen is having many porosity, it gets filtered. That means filtration is a process by which the larger particles can be removed physically or manually. This is what is called as a filtration. And sedimentation is nothing but settling up of the waste substances like soil, sand, small pebbles, etc. Okay, so this is what is termed as sedimentation. So let's see what is filtration. So filtration, it is the process of removal of large particles physically. So removal of large particles physically. This is called as a filtration. So here, physical removal of larger particles. What are these larger particles? The larger particles may be cardboards, plastics, or even the thermocol banks also. Irrespective of that, it has to be removed physically. It has to be picked out by someone, which is called as a filtration. This is the process of filtration. Then what is sedimentation? This is the second part. What is exactly the part of sedimentation? We'll see the part of the sedimentation. So sedimentation is nothing but it is the process of settling of waste substances in the primary tank. In the primary tank, like soil, sand, pebbles, etc. So almost these are having little bit of weight these substances settle at the bottom of the tanks, and those tanks are called as primary tanks. So what are these tanks? So we have a diagrammatic representation of STP. With the diagrammatic representation of these STP, let's study what is the primary treatment, and second major part is the secondary treatment. Okay. So let's go with the diagrammatic representation of the sewage treatment plant. In this sewage treatment plant, we have primary as well as a secondary treatment, and let's see how the primary and secondary treatment is done in case of these STPs. Okay, now here we have the tank. We have different types of STPs. Here we are looking at one model of the STP. Okay. Now this is one model. This is an outlet. This is the first tank, where we call it as a primary tank. It's a primary tank. Here we have one more outlet pipe. Okay. Now here we have one more chamber. Now in this, the effluents are taken. This is the effluent where it goes. And here we have and a rotatory fan. Here oxygen is there, so it consists of oxygen. Now this is the inlet, this is the outlet. Now here we have an outlet. This tank, the first tank that we can see here, this is what is a primary tank. So this is now initially, whatever the primary treatment occurs, it occurs in this first tank where we call it as primary tank. And the sludge that comes out here, this is called as a primary sludge. This is the primary sludge. And this tank we call it as a aeration tank. This is the aeration tank where oxygen is supplied. This tank is called a settling tank. Here we have activated sludge. This this is the activated sludge. This is effluents inlet. Okay, so this is the effluent inlet, and here we have clarified effluents. Here we have clarified effluents. Okay. Now this is regarding the part of the sewage treatment plant, where we call it as a STP. So this is one model of a sewage treatment plant. The sewage water has to be treated, the sewage water has to be managed, and the pollution has to be reduced. Okay, so what is the primary treatment is done in the first tank, where we call it as primary tank. Here screens will be there, screens will be placed. The process of filtration and sedimentation occurs. Filtration is a physical removal of particles, where all the particles will come and flow. It is removed physically. They are removed physically. Sedimentation means when the effluents, when the sewage water comes, it carries a lot of impurities. Along with the soil will be there, mud will be there, sand, pebbles, all will come and settle here. When they come and settle here, now this it forms into a sludge here, where we call it as primary sludge, that gets settled at the bottom. The sand particles, soil particles, and the pebbles that can be removed. Okay, now here we will be having a controlling knob through which this sludge is removed. Sludge is nothing but it is the waste material that is formed in the primary tank. It is removed from time to time. Okay. When the effluents comes in the primary tank gets filled. The effluents from the primary tank will move into the next plant, where we call it as an aeration tank. The secondary treatment starts from this point only. Okay, then what is the secondary treatment? So here the secondary treatment will start. Okay, the secondary treatment will start here. The secondary treatment is also called as, there is one more name for this. The secondary treatment is also called as a biological treatment. This is also called as biological treatment. Secondary treatment is also called as a biological treatment. Why secondary treatment is called as biological treatment? Because we are using biological microorganisms, and hence this is also called as a biological treatment. Okay. Then what happens here? Let us come to this tank. We call this tank as an aeration tank. Why we call it as an aeration tank? Because we are supplying oxygen. That's why it is named as aeration tank. After supplying the oxygen to the effluents and the microorganisms which are present here, the microorganisms will multiply rapidly and it forms into a masses of bacteria along with the fungal filament. This is now called as a flux. This is now called as a flux. What are flux then? The masses of bacteria along with fungal filament is termed as a flux. This is most important because it will be asked for the definition type of questions. What are flux? The masses of bacteria, that means a group of bacteria along with the fungal filament that forms into a mesh-like structure. It forms into a mesh-like structure. This is what is called as a flux. So we along with the fungal filament that forms into mesh-like structure. This is what is called as a flux. Okay. After forming the flux, here we are having a rotatory fan. connected with the blade. When the flocks are formed, the flocks has to be broken. How it is broken? This shaft is connected with a motor. It starts to rotate. When it starts to rotate, it leads to agitation. Agitation means a proper mixing up of the sewage water. And the flock is broken, the microorganisms, the bacteria released. Now those bacteria are useful bacteria in the STPH. Now, when they are released, these microbes act on the organic matter present in the sewage water, and this organic matter is converted into inorganic matter so that the BOD can be reduced. The question comes, what is BOD? So let's come to the part of BOD. BOD is biochemical oxygen demand. Biochemical oxygen demand. How it is defined? So how that BOD can be defined? So BOD can be defined as the amount of oxygen required by the microbes to oxidize the organic matter present in 1 liter of water. The amount of oxygen required by the microbes to oxidize the organic matter present in 1 liter of water. This is what is termed as a BOD. So BOD is the amount of oxygen required by microbes to oxidize the organic matter present in 1 liter of water. This is what is termed as a BOD. So BOD is the amount of oxygen required by the microbes to oxidize the organic matter present in 1 liter of water. That means the BOD has to be reduced. Why the BOD has to be reduced? What will happen if the BOD is not reduced? Microorganisms also require oxygen because these are aerobic microbes. Aerobic means that depends on oxygen. Now, when they utilize oxygen, they will act on the organic matter or the organic debris. Debris refers to the vegetable waste, the fruit waste which is present in the sewage water. It has to be broken down. To break down this organic matter, microorganisms will utilize the oxygen. So that's why more the BOD, more the pollution potential, less the BOD, lesser the pollution potential. So we use it higher the BOD, higher the BOD, higher the pollution potential, and lower the BOD, lower the pollution potential. Look at this part. If the BOD is high, pollution potential is also high. If the BOD is less, water pollution potential is also less. That means if microorganisms are extracting more oxygen, water is more polluted. If microorganisms are not utilizing more oxygen, that means the BOD is reduced. That means the water is less polluted. In the aeration tank, look at this part. In the aeration tank, initially the BOD will be very high. Microorganisms will be acting on the organic matter, it breaks and it converts into inorganic matter. Now, initially the BOD is very high. We are supplying oxygen continuously. Now, when BOD reduces in the aeration tank, the effluent, we don't call it as water, it is the effluent because it is a wastewater. That effluent is taken into the next tank where we call it as a settling tank. In the settling tank, this effluent is allowed to settle down. The effluent is allowed to settle down. And the mud which is present here, it settles at the bottom. It forms into activated sludge. Then what is this activated sludge? This is also most important. So here activated sludge refers to activated sludge. Then what is this activated sludge? Activated sludge is nothing but this is the sludge which is rich in microorganisms. It is the sludge that contains aerobic microbes, and hence we call it as a activated sludge. So the activated sludge is formed here. This activated sludge contains the waste mud along with the useful aerobic microorganisms. Then what is the use of this activated sludge? Suppose if the microorganisms is less in the aeration tank, this can be reused, this can be pumped back. This can be pumped back. Which one? Activated sludge can be pumped back into the aeration tank so that the microorganisms can be increased, so that the VOD can be decreased very soon. Right? So that's why the activated sludge can be reused. Okay. Then after settling here, after formation of the activated sludge, the effluent which comes out here, this is called as a clarified effluent. Okay, suppose let us say in the inlet, if the effluent is 100% polluted, and in the outlet it is 70% free from impurities. That means it is not 100% clean water, but at least 70% of the impurities has been removed. And this clarified effluent can be used. So this effluent can be used for agricultural purposes also. Okay. So it is unfit for the domestic use, but that waste water can be used for the agriculture, where lot of impurities can be removed. Now the clarified effluent, now it can be released into the aquatic water bodies like rivers and streams, and even for the lakes also. Now if we release this clarified effluent into the aquatic water bodies, it does not damage the aquatic life that much. So that's why this is the main intention of STP. Okay, sewage treatment plant. Now next, let's go to the next part, activated sludge. What will happen to the activated sludge? The remaining activated sludge is pumped into another tank where we call it as an anaerobic sludge digester. So let's look at the tank. The next tank that we come across is an anaerobic sludge digester. Let's look at its structure. This is the anaerobic sludge digester. Now here we have an inlet pipe. Here we have a gas pipe. This is methane gas. This is the floating chamber. Consisting of methane gas. And here we have this is the inlet. This is sludge inlet. Okay. Now this is the sludge, and this side we have the spent sludge. Okay, now this is called as anaerobic sludge digester. This is anaerobic sludge digester. Now what is done in case of this? Look at this part. The activated sludge which remains here, this activated sludge is pumped into another tank. This tank is an anaerobic sludge digester. Through the inlet we are using this activated sludge. This activated sludge consists of aerobic microbes. Now, in this anaerobic sludge digester, as the name says, anaerobic, there is no oxygen. There are certain anaerobic microbes which acts on these aerobic microbes as well as the sludge present in it, and they will produce the methane gas. And the methane gas which is produced here, what does it contain? So the methane gas which is produced after action of the anaerobic microbes, the methane gas is produced, which is connected to a pipe, and that methane gas can be used for cooking purpose as well as lighting purposes also. Okay, now here the gas is produced in SCPs are CH4, CO2 and H2S, hydrogen sulfide. Now methane gas, carbon dioxide along with the hydrogen sulfide is produced. So these are the most important gases that are produced in the STP. Remember which are the gases that are produced in STP. Okay, so here CH4, majorly is methane gas, carbon dioxide along with hydrogen sulfide. H2S is also produced. Okay, so this is regarding the part of the biogas. Even the biogas is also produced. We can call it as biogas, methane gas, which is produced from the activated sludge. This is produced by sewage treatment plant. Okay. Then the use of sludge, the sludge which is used is removed. It's called as spent sludge. This is removed from time to time. This is how the waste water, the sewage water and the municipal water pollution is controlled. Okay, now this was the STPs for the first time was initiated by the Ministry of Environment and Forest. So who has initiated it? So this was initiated by STPs were initiated by the Ministry of Forest and Environment under in the last part of the STPs, the Ministry of Forest and Environment have taken 2 action plans. The Ministry of Forest and Environment have taken 2 action plans. So they have taken action plans to preserve the water, river water, especially the 2 action plans which were taken by the Ministry of Forest and Environment are, the first one is a Ganga Action Plan, and the second one is Yamuna Action Plan. Look at these 2 parts. The Ministry of Forest and Environment have taken 2 action plans so that the river water pollution has to be protected and it has to be prevented. The first one is a Ganga Action Plan, second one is a Yamuna Action Plan. As we know, Ganga is the holy river of India as we worship it, and hence the pollution of the Ganga river has to be prevented, because in the previous days we came to know that Ganga river was a highly polluted river, and hence due to the action plans taken by the government of India by implementation of sewage treatment plants, the Ganga river pollution has been reduced. It has been stopped now. Okay. So this is regarding the part of the Ganga action plan. Similarly, Yamuna, again it is a great river in India. The pollution of the Yamuna river has to be preserved, has to be stopped. Now why we have to conserve our rivers? Because the rivers are the sources of water for the survival of the human beings, and hence if we pollute water and we are using the same water in our day-to-day life, it will cause a lot of diseases to the humans, and hence the main step taken by the government of India under the Ministry of Forest and Environment is these two action plans. This is to save our river water from getting polluted. Okay, the main intention of the STP is, first one is reduce pollution of the water. Second, minimize the use of water, save water, and ultimately what we give to the nature, the same nature gives back to us. And hence, let us conserve, preserve the water pollution, and let us save our rivers also. Okay, so with this we will end it with the STPs. Thank you.